Okay, so imagine you hire a new employee. Let's call him Bob. Bob is, bright, enthusiastic, eager to please.
Hmm.
On his first day, you give him a complex task, say, organizing a totally chaotic digital filing system that hasn't been touched in 5 years.
A fun first day.
Right. He struggles a bit, makes a few wrong turns, maybe deletes a folder he shouldn't have, but eventually, by 5:20 p.m., he figures it out, he cleans up the mess. Great.
Sounds like a standard is slightly bumpy
Yeah,
onboarding process. I mean, everyone trips up on day one.
it would be. But here's the catch. The next morning, Bob walks in, sits down, and he has absolutely no memory of yesterday.
Oh,
None. Zero. He opens the computer, makes the exact same mistake, struggles with the exact same files, deletes the exact same folder again, and you have to guide him through the whole process every single day.
that sounds like a management nightmare.
Yeah.
That's basically the movie Groundhog Day, but for, workplace productivity.
Hmm.
You're describing a worker with zero capacity for retained learning.
Exactly. And that is the frustration so many of us have felt with AI agents. We call them agents, these
Okay.
systems designed for multi-step tasks, but they have this persistent structural amnesia.
It's a fundamental limitation of the current architecture. We have these incredibly powerful large language models, but they largely operate in isolation, per session. They don't naturally carry over wisdom or lessons learned from one attempt to the next.
They have a high IQ, but no memory.
Zero long-term memory for their own mistakes, yeah.
Well, today we are unpacking a paper that basically says, enough of the amnesia. It is titled Skill-Augmented, Evolving Agents via Recursive Skill-Augmented Reinforcement Learning. It's from a team at UNC Chapel Hill, UCSD, and a few others.
Right.
And the mission of this deep dive is to figure out how they are curing this.
And to be clear, we aren't just talking about giving the AI a bigger hard drive to log everything it did. This isn't about storage.
Yeah.
It's about synthesis.
Because as we're about to find out, logging everything is actually part of the problem.
It is. We're looking at how to teach an AI to build a skill set. Essentially, giving the AI a playbook that evolves and gets smarter the more it practices, just like a human mastering a craft.
So let's unpack that. Before we get into the solution, SkillRL, we need to understand why the old methods don't work. You said logging everything is a problem. I thought the whole point was to just save a transcript and feed it back in.
That's been the standard approach, yeah. It's often called memory-based methods.
Yeah.
The idea is simple. Record the raw trajectory.
Trajectory just being the fancy term for the transcript.
Right. Every action, every observation, every thought the AI generated, you save that to a database, and next time the AI retrieves it. On paper, it sounds logical. Here's what I did last time.
It fails.
It fails because of the signal-to-noise ratio. Think about it this way. Suppose you want to learn how to cook a perfect omelet.
Okay.
You ask a master chef. Now, what if, instead of a recipe, the chef just hands you a literal second-by-second transcript of everything they did in the kitchen for 3 hours?
Oh, wow. So I walked to the sink, I washed my hands, I dropped the spoon, picked up the spoon, hummed a tune.
Precisely. It's full of noise, it's redundant, and buried in there somewhere is the actual important part. Heat the pan before adding the eggs. But good luck finding that in 3 hours of raw logs.
And that's what we were feeding our AIs.
No. You create token overload.
Because the AI has a limited context window. It's short-term working memory.
Correct. If you fill that window with, I dropped a spoon, you are wasting cycles and, more importantly, distracting the model from what actually matters. The paper is really clear on this. Raw memories often degrade performance because the AI gets lost in the weeds.
You know, the paper makes a really interesting point here about how humans learn. We don't remember raw trajectories.
We absolutely don't. When you learned to ride a bike, you didn't memorize every single muscle twitch.
No.
You abstracted that experience into a skill, balanced by leaning into the turn.
That is the key word, abstraction. We turn experience into skills. And that is precisely what this SkillRL framework is trying to do for AI.
That's the core insight. SkillRL bridges that gap between the raw, messy experience and actual improvement. It does this by distilling experience into skills.
Okay, distillation. I love that word. So let's talk mechanics. How does the AI know what's a skill versus what's just dropping the spoon? The paper talks about a teacher model.
Right, so in this setup, they use a stronger, larger model, in this case one of OpenAI's models, to act as the teacher for a smaller, more efficient agent. The teacher's job is to basically look at the game tape.
So the agent tries a task and the teacher reviews its performance.
Yes, and it handles success and failure very differently. If the agent succeeds, the teacher looks at that run and extracts the winning strategy. It summarizes why it worked into a positive skill.
Makes sense. Keep doing that. But what about failure? I feel like most systems just delete the failures. Oops, didn't work. Throw it away.
And that is such a waste of data. I mean, failure is often more educational than success. SkillRL leverages what they call counterfactual reasoning.
Counterfactual reasoning. That sounds intense. What does that actually mean?
It means the teacher model looks at the failure and asks, where exactly did this go wrong? What was the flawed logic? And critically, if the agent had done X instead of Y, would it have succeeded?
So it turns a failure into a rule, like, I tried to pick up the hot pan with my bare hands. The lesson isn't I failed. The lesson is always use an oven mitt for hot pans.
Exactly. It identifies the causal link, and that lesson becomes a skill in the library. And speaking of that, we need to talk about the skill bank.
The skill bank. It sounds like a vault. But it's not just a pile of text files, right? It's got to be organized.
It does. I mean, if you just had a list of 5,000 random rules, the AI would spend all its time just reading them.
And no time doing the work.
Right. So SkillRL organizes this hierarchically. You have general skills and task-specific skills.
Okay, give me an example of a general skill.
That would be something that applies across different environments, like explore unvisited rooms first, or check preconditions before acting. These are just universal principles of being a good agent.
And task-specific.
That's more niche. The paper uses a cleaning task example. Locate the object, obtain it, clean it, place it. That sequence works for cleaning, but not for, searching Google.
And the efficiency of this is wild. I saw a stat in the paper, the compression rate.
Oh, yeah. This is where the abstraction really pays off. By turning those long, messy logs into a crisp rule like, don't turn on the microwave until you put food in it, they got a 10 to 20 times reduction in tokens.
That is massive. That's the difference between reading a textbook and reading a sticky note.
And getting a better result.
So we have the library, we have the skills, but the paper's title has the word recursive. So the library isn't static, right?
Right. This is the cycle of life for the skills.
Mm-hmm.
Most systems, they might give the AI a fixed list of rules at the start. SkillRL evolves the skills during their training process. The skills and the brain are growing together.
Walk me through that loop. How does it start?
Well, first, there's a cold start. You can't just hand an AI a rule book and expect it to know how to use it.
Yeah.
So they do a phase of supervised fine-tuning, where the AI just watches demonstrations of retrieving and applying skills.
So it learns the concept of using a cheat sheet before it actually writes its own.
Perfect. Once it knows how to use the library, the real loop begins. The agent tries tasks. Eventually, it fails a validation task, and the system immediately catches that failure.
And the teacher model steps in again.
Right then and there. It analyzes the failure, generates a new skill, or refines an old one to plug that specific gap. Then the agent tries again with the updated library.
So if it keeps tripping over a specific type of puzzle, it writes a new rule for that puzzle, adds it to the book, and tries again.
And this creates what they call co-evolution. The AI's internal policy, its brain, is getting smarter through reinforcement learning. And at the same time, its skill bank, its external cheat sheet, is getting more comprehensive.
It's like climbing a wall. Standard reinforcement learning is just jumping and hoping to grab a higher ledge. SkillRL is building a ladder as it climbs.
That is a perfect analogy. The skills are the stepping stones. They let the agent reach a level of complexity it just couldn't by guessing.
I want to make this concrete for everyone listening. Theory is great, but let's look at the case studies. They tested this on ALF World, which is a text-based household simulator.
ALF World is a classic benchmark. It simulates tasks like heat an egg and put it on the countertop.
Which sounds simple, but is incredibly tricky for an AI that can't see.
Very. So without SkillRL, the agent often makes this classic blunder. It runs to the microwave and turns it on, but it hasn't picked up the egg yet.
Classic. Trying to cook air.
Right. The microwave is running empty, the agent fails. Now the SkillRL agent, it pauses. It retrieves a specific skill from its bank called no appliance before object.
And that's a rule it learned from a past failure.
Yes. And you can see the reasoning trace. It explicitly reasons. Per skill, no appliance before object, I must not go to the microwave first. I need to find the egg in the fridge. So it creates a logical plan. Find egg, go to microwave, heat egg, place on counter.
It actually talks to itself like that, citing the rule.
Explicitly. It validates its own plan against its rulebook. It's like watching someone finally listen to good advice.
They also tested it on WebShop, the e-commerce simulation. This one felt very relatable.
Right. The scenario was buying a specific shirt. Women's long sleeve button down in navy blue, Size large, under $40.
That's a lot of constraints. Style, color, size, price.
And a standard AI often gets distracted. It sees suggested items, or a shirt that's blue but not navy, or it forgets the price limit.
I do that too, to be honest.
Yeah.
Oh, look, this one's prettier. Who cares if it's $50?
We all do. But the SkillRL agent retrieves two skills: prioritize core keywords for the search bar and check variant price for the logic.
So it knows to ignore the fluff.
It searches for the navy blue variant. It finds one for $29.00.
Huh.
It does the math, explicitly confirming that 29.99 is less than 40.000 and hits buy now. It's clinical. It doesn't get sidetracked.
It's disciplined. That's the word. It's following a protocol that it helped write.
Exactly.
Now let's talk results, because big ideas are nice, but in the AI world, benchmarks are king. And this is kind of a David versus Goliath story.
It really is. They used a model called Qwen 2.57b. In the world of LLMs, 7 billion parameters is, well, it's smallish.
Right, not a lightweight, but not a heavyweight.
Definitely not.
Yeah.
And they put it up against GPT-4o and Gemini 2.5 Pro.
The heavyweights, massive closed-source models running on supercomputers.
And on the ALF World Benchmark, SkillPart didn't just compete. It absolutely trushed them.
Give me the numbers.
GPT-4o had a success rate of around 75%.
Yeah.
SkillPart's approximately 90%.
Wow, that's startling. A small open-source model beating GPT-4 up by 15 percentage points. That shouldn't happen based on raw power.
It proves that a smart process beats raw horsepower. GPT-4o is a genius, but if it doesn't have a structured way to learn from its mistakes in that specific environment, it will keep making them.
It's the difference between a genius who doesn't study and a smart kid who has a perfect system of flashcards.
And who creates new flashcards every time they get a question wrong.
They also tested it on search-augmented QA, right? Answering questions by searching the web.
Yes. On the Bamboogle dataset, which is designed to be tricky, it requires multi-hop reasoning. You can't just find the answer on one page. You have to connect dot A to dot B to dot C. Significantly better than the baselines. The skills helped it navigate. Instead of getting lost in Google results, it had skills like verify source credibility or synthesize conflicting info. It kept the agent on track.
And I want to highlight the graph in the paper on prompt length. We talked about token overload.
This is crucial for deployment. While the memory-based methods spiked up to 1,500 tokens or more as they got clogged with logs,
Right.
SkillRL stayed consistent and low even as its performance went up.
That efficiency is so important. We can't have an agent costing $50 in compute just to book a flight because it has to read a novel's worth of logs every time.
Exactly. Cost and latency. SkillRL is leaner and meaner.
So what does all this mean for us, for the listener? We've got this system that turns failure into wisdom.
I think the big takeaway is the shift from data to wisdom. For a long time, the AI hype has been about more data, more parameters, bigger context, just shove more info in.
And this paper says no, structure matters more.
Structure and reflection. SkillRL works because it stops to think about why it failed. It forces a moment of reflection to distill a lesson.
It makes me think about my own work. When I mess up a project, do I just move on and hope I remember not to do it again? Or do I actually write down a rule?
That's the difference between raw memory and a skill. Raw memory is just the embarrassing flashback. The skill is the checklist item you add. Check HDMI cable before meeting. SkillRL is automating that.
Before we wrap up, I have a thought that's been nagging me. We talked about the AI writing its own skills. It wrote, 45 new rules in this experiment?
Right.
And these rules were in English, so the researchers could read them. Don't use microwave empty. But what if we let this run for a year on something like complex code?
Yeah.
Or financial markets?
I see where you're going.
If the AI is writing its own instruction manual based on failures that only it fully understands, at what point does that manual become so complex that we, the humans, can no longer comprehend the rules the AI is following?
That is a profound question.
Yeah.
We often talk about the black box of neural networks, right? Where we don't know what the neurons are doing. SkillRL creates a white box, a list of explicit rules.
But if the list is 1 million rules long and they all reference each other, per skill 4D056 reference skill 802.
Then the white box becomes effectively unreadable to us. It becomes a bureaucracy of skills that works perfectly, but we don't know why. We might end up with an AI that's incredibly competent, following a strict code of conduct.
But we have no idea what that code actually says anymore.
An alien bureaucracy of its own making. It's a very real possibility. We might need skill interpreters, AIs whose only job is to read the skill library and explain it back to the humans.
A whole new job market, AI skill translator.
Always look for the silver lining.
Well, on that slightly terrifying but fascinating note, we are going to wrap up this deep dive into skill. It's a huge step forward, moving from amnesiac agents to ones that build wisdom.
It really is. The shift from memory to skill is the future of agentic AI.
Remember, next time you fail at something, don't just feel bad. Distill a skill. Be like skill.
Write the rule.
Thanks for listening, everyone. See you on the next deep dive.
Goodbye.